Welcome back to College Algebra. In this lecture video, let's take a look at determine the domain of a function defined by an equation. So the reason why I say defined by an equation because the next objective is actually determine whether the graph is a function or not. So it's defined by the graph. So I made this into two different objectives. The purpose here is simply by looking at these functions, okay, in terms of equation and write down the domain. The next objective is actually looking at the graph and determine whether it was a function or not a function. So this very first one, I'm wondering if you see that this -4 plus 2x minus x squared, minus x to the third, I want to see if you notice that this is actually a cubic function. Because this is a polynomial function, because my highest exponent is 3, so that actually considered as a cubic function. So as you can recall from objective number 2, a cubic function normally looks like this, okay? But this x to the third is positive. Our x to the third is actually negative. So positive x to the third looks something like this way. So for our negative x to the third, it will actually look this way. Okay, so without graphing, if you graph it, you will actually see the same thing here. So just by knowing that this is a cubic function, I know my domain got to be from negative infinity to infinity. All right, this one is a radical function. All right, this one is a radical function, but normally, to be more specific, this is a square root function. So square root function of x normally look like this, okay? But there's a negative sign right in front of my x as well. So this picture will still look something like this, maybe not turning this way in particular. So we can actually graph this in a little bit just to know exactly what this thing look like to help us write the domain. So to know where the domain of a square root function begins or ends, we will set what's inside the square root equal to 0 to give us an idea. So that's negative x plus 3 equal to 0. Move the negative x over, so that will be x equal to 3. All right, so I know my domain will either end or begin at x equal to 3. So let's graph it and kind of see what this thing looks like. Just out of curiosity. So square root of negative x plus 3. All right, minus 2 on the outside the square root. So I'm going to close my parenthesis, then type in minus 2. If not, then my minus 2 will actually be inside the parenthesis. That's why I had to close it. Okay, it actually looked like this. So by knowing, by finding where the domain begins and ends from the beginning, moving it too fast. Well, let me just do it right here for right now. All right, so it actually went to the left side. So by finding out that ahead of time, the 3, that actually tell me my domain actually ends at 3. All right, so from left to the right, okay, my domain got to be coming from negative infinity all the way to 3. And since 3 is actually on the line, I will actually use a bracket. All right. Cut that out. Put it right here. So this particular point where it ends at. All right, so a lot of students say, well, I'm just going to do this just by looking at it. Well, be careful now, because if I would say this is square root of negative 2x plus 3 minus 2, then your ending point will actually be a fraction. So you will still end up have to solve, okay, for x anyway to know what the ending point is. Okay, so be careful. There's a lot of teachers teach a different way, but I think the easiest way is just simply by setting what's inside the square root equal to 0. So you know where the function begins or ends. I think weird stuff like negative x plus 3 is lesser than 0, greater than 0 before. I'm not quite exactly sure what was the purpose of it, because you're still solving for x still. Okay, so I think they teach it this way is basically trying to show you that the graph is actually pointing to the left. Okay, but to know what the domain ends or begins, you still got to solve for the x, and that's located inside the square root. Okay, there's another objective I'm going to show you exactly how to look at this equation and know exactly what the graph will go to the right or go to the left. Okay, that will be a different objective. All right, let's look at this rational function right here. So the first thing we do with rational function is find its restriction on the domain. So I'm going to set my denominator not equal to 0 and solve for x. Move the negative 1 over. That's 2x cannot equal to 1. X cannot equal to a half. All right. So my picture will probably look something like this way. Well, probably this is actually the first power, so I kind of know it may look like something like this one. Okay, it will be look like the one on the left right here. So just to be certain, it doesn't hurt to graph it. So I'm going to say parenthesis x minus 4 divided by 2x minus 1. Okay. Well, it look like this way. Okay, so that confirms it. Okay, so my x, I know my x cannot equal to a half. So once I keep on going left, the other side keep on going to the right. So on the left side of my restriction, my domain must be coming from negative infinity all the way to the half. All right, use parenthesis for the half. Okay, union. And the other side of the restriction on the domain is going to be starting at half, but not exactly half. That's why I use parenthesis all the way to infinity. Okay. All right. This is a very interesting little problem right here. This is a rational function. Okay. So if I want to find the restriction on the domain, I will simply set my x squared minus 9 not equal to 0. So x squared not equal to 0, and that is a difference of square. So that's actually x plus 3 times x minus 3 equal to 0. So when I set each factor not equal to 0 and solve for x, my answer, my x actually cannot be negative 3 and 3. So this problem, I actually have two restrictions on the domain. Okay, I actually have two restrictions on the domain. But it's funny though how I factored the x squared minus 9. That gave me x plus 3 and x minus 3. So if I write it out this way and say, okay, the x minus 3 on the numerator cannot be factored other than 1. So, and I put them in a parenthesis. The x minus 3 will cancel each other out. So that actually gives you 1 over, okay, x plus 3. So this is my resulting function, okay, after I simplify. But I actually need to go back and type in the original function, because whenever I'm simplifying a function, okay, then I might be losing certain characteristic of that original function. So the resulting rational function here, I'm already losing, I might have lost or lost some characteristic. So I don't want to graph the ending one. I actually need to go back and graph the original function. Okay. So just in case if I lose certain characteristic, okay. So very cool problem. The rule of thumb is you always graph the original one before you simplify them. Okay, especially before you simplify. That's the function you got to key in the calculator. Just in case some characteristics get lost along the way while we simplify. So I'm going to say parenthesis x minus 3 for the two term on top divided by parenthesis again x squared minus 9. So ahead of time, I already know I got two restrictions on the domain. Okay, so think about this. Why the graph look like this? Because my rational function is really 1 over x. Okay, my basic function is actually 1 over x, where the x is r power. So r power will look anything like this. Okay, so this graph simplified become this. So no surprise, this function should match that picture, but I actually have two restrictions on the domain. So if you look at that picture and say the domain is from negative infinity all the way to -3, union from -3 to infinity, that will be incorrect, because I actually already previously found there's actually two restrictions. That's the reason why you never just think about it. Think about this domain as the resulting function. You actually think about the domain as the original, okay, as original function you started. That's why I graphed the original function. So my domain is actually from negative infinity all the way to -3, union, okay, look on the graph. From -3, my function actually still keep on going to the right, but there is actually a restriction on the 3, so my domain is actually from -3 to 3, because I can never be 3 exactly. Union on the other side, on the right side of another restriction. So I got a restriction of -3 and 3. So I have my domain does exist on the left side in between the two restrictions and on the right side of my second restriction. That's why this domain is actually divided up into 3 parts. So the other side, my last part of the domain got to be on the right side of my restriction of 3. So the other side got to be from 3 to infinity. Okay, there's actually 3 parts on the restriction of the domain. So if I start you off with simply just 1 over x plus 3, then there's only going to be one restriction, which is divide my graph into 2 parts. Okay, but this problem originally actually had 2 restrictions. That's why I should have 3 parts, okay, on my domain. All right, let's look at this one. This is a very interesting problem too, because since both numerator and denominator is under the same square root, we can actually rewrite this entire function as big old square root of x minus 4 over x minus 6. So this is not quite a rational function. It's not quite a square root function. Okay, it's a combination of the two. All right, so knowing that, hopefully that will help us, okay, keep in mind what's going on, when we write out the domain. So let's look at the numerator. Okay, where does my domain will end or begin? If I'm just thinking about the numerator, square root of x minus 4. Well, let's see. I know that x minus 4, if I set it equal to 0, x is equal to 4. So my domain can begin or end at 4. Denominator here, okay, if I would find the restriction on the domain, then x minus 6, right? Set what's inside the square root, or if I set my entire square root of x minus 6 not equal to 0, it'll still come up with the same answer. X cannot equal to 6. Because 6 minus 6 is 0, square root of 0 is make my whole thing undefined. All right. So I got one restriction here, and my domain can begin or ends at 4. All right. So let me graph this to kind of look at the picture and know exactly what's going on. The square root of x minus 4 is actually only one term on top, so I don't need extra parentheses. So I'm just going to say square root of x minus 4. Make sure the x minus 4 are in the parentheses for the square root, because that indicates that both terms are inside the square roots, divided by another square root of x minus 6, close parenthesis, and here we go. This is my picture. That is bizarre. That's it. That is kind of a weird looking thing right there. So 1, 2, 3, 4. Well, hold on now. I thought my domain starts at 4. Well, for the numerator part, it is at 4. But my denominator is actually a square root of x minus 6. So if I'm thinking about the starting point for my domain, starting or ending point for my bottom square root of 2, that is actually at 6. Okay, cannot be exactly 6, you know what I'm saying? Because that's actually one of my restrictions. So which one do I pick? Do I start or ends at 4 or 6? Well, apparently it got to be at 6. Because the x that you pick got to satisfy every parts, got to satisfy every parts of your function. Because if you say starting at 4, okay, 4 minus 4 is 0. Square root of 0 is 0. No problem. 0 on top is okay. But if you put 4 down here, if you put that same 4 in the bottom, 4 minus 6 is actually negative 2. Square root of negative 2 is actually not a real number. So therefore, it does not exist on the real number line. So that means anything from 4 to 6 actually does not exist. If you look on the table, you will see it. At 6, it's going to be an error because that's my restriction. But anything from 4 to 6, right? You know, like 4.1, 4.2, any one of those decimals between 4 to 6, actually is going to be undefined. Okay, because the same number I pick for x got to go on the top and the bottom square roots. So interestingly, my domain actually will start as 6 and keep on going to the right. But do I use parenthesis or bracket for this 6? Well, it got to be parenthesis because remember, 6 was a restriction on the domain. Okay, so by having starting at 6, but since it's a restriction 2, that's why I use parenthesis. Okay, so that is actually my domain for this problem. So doesn't hurt to find the restriction ahead of time, and it always help to actually graph, okay, to actually graph our functions, to know kind of exactly what's going on with our radical functions or rational functions, okay? All right, that will conclude this video. Thank you for watching.